Thanks for joining us today again for another episode of the Weiler Wednesday webinar. My name is Nate Schmidt. I'm the Director of Marketing with Weiler Abrasives, and I'm excited today to have Ron Vogt Jr. joining me. He's our Category Manager for Maintenance, Repair, and Operation, and he's been with Weiler for 32 years. So we've got quite a bit of knowledge around power brushes, which he's going to share with us today. Not that we're counting, Ron, but congratulations on 32 years with Weiler.
Thank you.
And thanks for joining us. Before we go ahead and get started, just a couple tips on Zoom. We have muted all lines so that we prevent any background noise. And we will take questions and answers throughout the webinar today. You can do that via the Q&A function in Zoom. So if you have a question, submit that question at any time during the webinar, and we will answer as many questions as we can at the end of the webinar. Again, submit those questions through the Q&A function down at the bottom of the Zoom bar. In addition, we'll have a contest about halfway through the webinar. You'll have a chance to win a prize, and you can submit your answer via the chat function. That's how we'll take the answers to that contest, and we'll announce that when we do it. And then lastly, we do a couple polls throughout the webinar as a way to get audience interaction, and we'd encourage you to take those polls as they pop up on the Zoom screen. Before we get into the topic for today, just a couple quick updates on our response to COVID-19. Obviously, it's been a challenging time for all of us, and we do want to let you know that we continue to operate our facilities around the globe and continue to produce our products and deliver them to many of the mission critical industries that continue to operate today. Just one example here on the slide is food manufacturing, and you'd be amazed, and many of you know how many different industries our abrasives and brushes go into. So we continue to operate, and we wouldn't be here today without our coworkers in our factories throughout the globe that continue to operate all of our machinery and keep us up and running. So I want to send a thank you out to them, and again, appreciate the work that they're doing to keep us up and running and to allow us to deliver those products to each of you. In addition, just a quick note, we will be getting our sales team back in the field, and they'll be taking the precautions and safety measures similarly to what we're employing in the factory floor. So I want to make sure that you're aware that we'll be taking those safety measures, and look forward to re-engaging in your facilities as we move forward, and that'll be done in a phased approach in accordance with local guidelines moving forward. If you have any questions or are looking for an update on our response, you can go to our website, weilerabrasives.com. I'd also encourage you to follow us on our social media channels, Facebook, Instagram, and LinkedIn. So without further ado, I'm going to hand it over to Ron to cover the topic of tips and tricks for power brush selection and performance. So Ron, take it away.
Good afternoon, everyone. Today we're going to talk about wire brushes. Wire brushes come in thousands of configurations and can be used for many different applications. Today we're going to focus on products used for handheld tools and small stationary tools, meaning bench grinders, pedestal grinders, angle grinders, die grinders, air tools, those type of small stationary and handheld tools. Wire brushes are classified in most of our distributor partners' catalogs with abrasives, but they are different from abrasives. Yes, they can be used for some of the same applications, but the way they perform these applications is very different. Wire brushes work like a bunch of tiny little hammers to remove surface contaminants. We call this peening action. When I say contaminants, I am speaking of paint, rust, dirt, oxidation, any other contaminants that may be on the surface of a metal. These little hammers strike the work surface and remove the contaminants and throw them off of the surface. Abrasives, on the other hand, dig into the surface to remove the contaminants, thus performing a different action. Next slide. Next slide, please. So as stated before, power brushes and abrasives can be used on the same types of applications. So let's talk about some advantages of wire brushes versus hard abrasive wheels. First, wire brushes conform to irregular surfaces more readily. Picture diamond plate, and you wanted to remove paint and rust from the plate. A crimp wire brush would conform and clean around the diamonds of the plate. A hard abrasive wheel would bounce off the diamonds and want to grind them down or completely off of the plate. Secondly, wire brushes do not load or clog when used on softer materials. Hard abrasive wheels generate a lot of heat, and as this heat builds up, some of the metal from the surface will adhere to the surface of the abrasive wheel. With wire brushes, the heat dissipates and the brush removes the contaminants without the softer material sticking to the brush. Thirdly, wire brushes always leave a smooth edge. If you look at the part in the photo, the hard abrasive wheel grinds and leaves a sharp edge on the part. The wire brush leaves a nice rounded edge. And finally, wire brushes do not remove base metal. This is the most important advantage to wire brushes. If you only learn one thing in this training, this should be the key takeaway. Hard abrasive wheels remove the contaminants, rust, dirt, oxidation, etc. from the surface, but also they take away the base material. They will probably work faster than a wire brush, but if you are concerned with not changing the part parameters, then a wire brush is the right product for the job. Please note the illustrations to the left and right of the photos showing the brush removing the surface contaminants and the abrasive wheel doing the same, but it's also removing base metal at the same time. Next slide, please. So as we choose the right product for the job, there are 4 things to consider. First is the tools that are available. Is the part small enough to be taken to the tool? Then a bench or a pedestal grinder is a good way to go. If the part to be brushed is larger, then a portable tool such as a angle grinder, die grinder, air tool is the best option. Second, what is the application being performed? Is it cleaning holes or bores, weld cleaning, deburring, surface prep? This will point you in the direction of the product to be chosen. Third, what is the material that needs to be brushed? Steel, stainless steel, aluminum, titanium? This will determine the fill material in the brush required to perform the job. And finally, wire brushes come in 4 major configurations. Wheel brushes have a narrow footprint, so brushing width is limited. Cup brushes have a much larger footprint for use on larger surface areas. End brushes are designed for use in recesses, inside diameters, and hard to reach areas. Tube brushes are for use in holes or bores, whether they are threaded or unthreaded. Knowing these 4 things will help you in selecting the correct wire brush. Next slide, please. Choosing the proper fill material. We use various different fill materials in our wire brushes. The first is non-ferrous wire, and this is for non-sparking applications. We use brass wire in our crimp wire products, and we use phosphor bronze or bronze wire in our knotted products. Next is steel, and the first steel is heat-treated, oil-tempered, high tensile. This is the best wire available out in the market that we use in our Weiler branded products. Next is a hard drawn wire, which we use in our Wolverine products for occasional use for the not the everyday user or the high volume user. And the last is low carbon wire, and we use low carbon wire in our finer wire. Finer wire diameters, 3,000s, 5,000s, 6,000s, where higher carbon wires are hard to draw down to these small diameters. And in this drawing process, they have a tendency to break if there's a high carbon content in these wires. And then the last wire that's used in our brushes is Type 302 stainless steel. And it's widely used in the manufacturing of power brushes for its relative durability and aggressive action, as well for its austenitic properties that ensure the corrosion resistance of the materials on which it's being applied. We also manufacture brushes with Type 316 stainless steel, and it's available on special request, and we have a limited offering of products with 316 stainless. Although 302 stainless is typically a non-magnetic material, it is important to remember that the amount of cold working that it experiences during the wire drawing process causes it to become magnetic. For this reason, proper storage and handling of stainless steel brushes is critical to prevent cross-contamination and after rust. So what does that mean? So if you're working with steel and you have a stainless steel brush in the area, you want to make sure that you don't store that stainless steel brush there, because some of the steel particles may adhere to that stainless steel brush and then be brushed on to a stainless steel part, and that's what causes the after rusting, is the steel being transferred onto a stainless steel part. Next slide, please. So what influences power brush performance? First is its wire configuration. We make brushes in two different types of wire configurations. One is crimp wire products for maximum conformability. Why is the wire crimped? The wire is crimped in our power brushes in two directions, north and south and east and west. We do this because if the wire is crimped in one direction only, the wires would just bunch together and give a very narrow brush face. By crimping the wire, the brush has a fluffier appearance and it gives the brush face more conformability. Knotted wire brushes use straight wire that is bundled and twisted into different configurations for maximum aggression and high impact action. This type of construction puts many wire points into a very compact area, allowing maximum impact and giving maximum aggression. This construction also makes these brushes very durable. Next slide, please. We have 4 different types of knots in our knotted wire products. The first one is a standard twist, and the standard twist has a tuft on the end that provides a little bit of flexibility so it can be used on some irregular surfaces. The cable twist is a tightly twisted, wider knot that's twisted tight all the way to the end, providing a very aggressive impact action. The stringer bead twist is also a very tightly twisted knot, but it has a reduced strand count that makes it a smaller knot so it can get into grooves, especially for root pass pipe welding and those types of things, so you can get into grooves. Especially, this brush was mainly designed for weld cleaning. And then the last twist is a hurricane twist, and it's a flattened out knot that the wires are twisted and the wire points point out toward the sides of the brush. This provides a smoother brushing action when in use. Next slide, please. As stated earlier, wheel brushes have a narrow footprint and a much narrower brushing face. Cup brushes should be used for large surface contaminant removal. You can see in the first picture the difference in brushing widths between a stringer bead and a cup brush. When it comes to using wire brushes, the faster you can get the job done, the better. Because let's face it, nobody wants to do this job, but they need to get done. Stringer bead wheel brushes have become the most commonly requested and used brushes in fabrication. But because a stringer bead knot was designed specifically for cleaning in very narrow root passes and gaps, there are several options for cleaning larger surface areas more quickly and efficiently in fewer passes. Look at the difference in cleaning width in the second photo between the 3 different knot twists. Quite a difference. If I was cleaning a top pass weld, I'd want to use the cable twist wheel based on the surface area that it cleans. And finally, the first angle grinders in the market were 4-inch. So when wire cup brushes were designed for this tool, the 2 3/4 brush was the go-to brush. When 4.5-inch angle grinders became the market preference, the 2 3/4-inch knot cups naturally migrated to be used on these grinders. But there's better options for the 4.5-inch angle grinder, and they are the 3.5-inch cup, which gives a much wider brushing face and 33% more wire points than the 2 3/4-inch cup brush. Next slide, please. Wire brush performance is also influenced by the diameter of the wire. The smaller the diameter of the wire, the more comfortable the brush is, but it isn't as aggressive. Typical brush wire diameter ranges from 5 thousandths to 35 thousandths. Just to give a point of reference to the diameter of the finest wire, Human hair is between 4 thousandths and 5 thousandths diameter. If you look at the chart above, for the most part, 14 thousandths to 5 thousandths wire is used in crimp wire products, and 011.8 and up is used in knotted wire products. There are a few exceptions to this, but this is the general rule of thumb. Larger wire diameter wires used in knot products to give it maximum aggression, and small diameter wires used in crimp products for conformability. Always remember that the wire tips and the tool speed do the work. So if you are applying too much pressure, you are not using the right brush. To maximize finish, always use the finest wire that will accomplish the job without applying excessive pressure. There are many more wire points in a fine wire brush, allowing for finer brushing finishes. Next slide, please. And finally, the last thing that influences power brush performance is fill density and trim length. Longer trim brushes offer greater flexibility. These brushes are built on smaller inner diameter, which limits the amount of wire that can be inserted into the brush, thus making them more conformable. High density, shorter trim brushes produce a faster brushing action, gives the brush longer life and a finer surface finish, but you will lose conformability in this style of brush. These brushes are built on larger inner diameters, so more wire can be inserted around the circumference of the brush. So picture you want to clean the rust off a threaded bolt. The longer trim brush wire gets down into the root of the threads and cleans the bolt completely, whereas a shorter high density brush will clean the rust, but leave some behind in the roots of the threads due to their loss in conformability. Next slide, please.
All right, so like I said, we're going to do a quick giveaway. We're going to give away a Weiler branded power pack, great for your mobile devices when you don't have access to an outlet. The first person to answer the question correctly in the chat function of Zoom will win the giveaway. So the question is, what is the key difference between wire brushes and coated and bonded abrasives? So again, put your answer into chat, and the first one to get the right answer in the chat function will win. We'll announce the winner at the end of the webinar. Back to you, Ron.
So let's talk about choosing the correct brush for your brushing needs. Next slide, please, Heather. Crimp wire wheel brushes can come in a variety of configurations. 6 to 10 inch wheels for bench grinders where the work is taken to the tool. They come in different face widths, narrow, medium, and wide, for different types of bench grinders. Bench grinder wheels can also be stacked together to make wider face brushes to clean much wider surface areas. Small diameter wheels, 1 1/4 to 4 inch, can be used with a drive arbor on die grinders and air tools, where the tool is taken to the workpiece. These brushes can also be permanently mounted on a stem. Can stem-mounted brushes be used on a drill? The answer is yes, but the performance is very diminished. The tool speed and the wire tips do the work. The closer you can run a wire brush to the maximum RPM without exceeding the max RPM, the higher the brushing performance. These stem-mounted wheels can also be made in a concave construction that can be used to clean corners and angles. Threaded nuts can be put on the brushes so they can be used on angle grinders. This can be done in 4 inch wheels to 8 inch wheels in diameter. Next slide, please. Knotted wire wheel brushes can come in a variety of configurations as well. 6 to 10 inch wheels for bench grinders where the work is taken to the tool. They come in different face widths, narrow and wide, for different types of bench grinders. Bench grinder wheels can be stacked together to make wider face brushes to clean much wider surface areas. Small diameter wheels, 3 inch and 4 inch, can be used on die grinders, again, with a drive arbor, and air tools where the tool is taken to the workpiece. These brushes can also be permanently mounted on a stem. The majority of knotted wheel brushes, though, are built with threaded nuts, so they can be used on angle grinders. We discussed these brushes earlier with the different knot twists. Nutted brushes range in sizes from 4 inch to 7 inch. Next slide, please. Cup brushes are built with a threaded nut so they can be spun right onto an angle grinder. They come in crimped and knotted in 2 3/4 to 6-inch diameters for cleaning large surfaces. For the most part, flat surfaces, but the crimp wire cup brushes can be used on irregular surfaces like diamond plate, for example. When brushing diamond plate, a knotted wire cup will clean somewhat around the diamonds, but they will tend to bounce off the diamonds. A crimp wire cup will clean much better and conform to the diamonds on this work surface. Keep in mind that a knotted cup will perform most flat surface cleaning tasks much faster than a crimp cup brush due to its high impact action and compact brushing area wire points. Knot cup brushes come in single rows of knots and double rows of knots. The double row of knot makes these brushes much more aggressive for heavy duty cleaning jobs. One downfall to these brushes is the weight, and after several days of use, your forearms will look like Popeyes though. Crimp wire cups also are available with 1/4 inch stems in 1.5 inch to 3-inch diameters for use on variable speed air tools and die grinders. Next slide, please. 1/4 inch stem mounted end brushes are high speed tools made for cleaning recessed areas and inside diameters. They are available crimped or knotted. Crimped end brushes come in the following diameters: 3/8, half, 3/4, and 1 inch. This measurement is the diameter at the bottom of the cup, not at the end of the wire. Knotted end brushes come in 1/2 inch, 3/4, and 1 1/8 diameters. End brushes can have rings applied to shorten the trim length for more aggression and also to help reduce flaring. Flaring will be discussed in more detail in an upcoming slide. A plastic coating can be added to the cup of an end brush to eliminate marring of the workpiece should the cup come in contact with the workpiece. We will discuss some other specialty end brushes later. Tube brushes, next slide please, sorry. Tube brushes or internal brushes are for cleaning holes and bores, whether they are threaded or unthreaded. These are low RPM products, under 2000 RPM, made for drills, drill presses, and CNC machining equipment. There are two major types of construction: single spiral, which uses one wire continuously wrapped to hold the wires in place. This is a general purpose style brush. Double spiral uses two wires twisted together to hold the wires in place. This creates a more durable stem for higher demanding, heavier duty applications. The other brush shown here is a butterfly brush. We call it a burrite. This brush is ideal for threaded holes. It is a single style construction with a tufted end. More wire points to get into the roots of those threaded holes. The other styles of brushes can also be used to clean threads should a longer brush be required. Tube brushes can be produced in a variety of sizes. Capabilities exist to make brushes in sizes from 14 thousandths in diameter to 12 inches in diameter and up to 6 feet long. They can have loops on the ends to be used by hand, or the loop can be removed to be used under power. We catalog around 400 different types of tube brushes, but have well over 2,000 item numbers available as specials. We can design all types of tube brushes for your application. Page 85 of our catalog has a special tube brush form, or you can access this form on our website. One thing to remember with tube brushes is always to rotate these brushes in a clockwise forward direction. If these were to be run in reverse, the stem wire may untwist and you'll be left with just a pile of wire in the bottom of your hole or bore. Next slide, please. So just a few tips on power brushes here. What is the number one complaint of any wire brush user? I'm constantly pulling wire. The answer is I'm constantly pulling wire out of my arms and shirt. And what's the cause of that? It's wire breakage, specifically long wire breakage. And what is the primary cause of long wire breakage? It could be either excessive pressure or excessive attack angle. And why do users overpressure any wire product? The common answer is it doesn't feel like it's working fast enough to get the job done. And the root cause of this is you're using a brush that's under spec for the application. So if you're using a crimp wire product, you may want to jump to a knotted wire product. Or if you're using a finer wire brush, you might want to use a coarser wire brush. Just a couple of different ideas there as to what may be causing you to apply excess pressure. Next slide, please. Orientation of a wire brush will help get the most out of your wire brush. So follow these simple rules and you will get its longest life and the most aggression from your wire brush. Wheel brushes should be used at 90 degrees to the work surface or straight up and down. Bevel brushes should be used at 30 to 45 degrees to the work surface, and cup brushes should be used at 5 to 15 degrees to the work surface. If you notice the picture in the top left, do not use a wheel brush in this manner. They are not intended to be used on the sides of the wire, and using them this way will cause the brush to fail prematurely. Remember the earlier slide with wire sticking in your shirt. Using a wheel this way will surely cause this to happen. Next slide, please. Over time, when a wheel brush is run in one direction, the tips of the wire may become dull and the brushing action will slow, causing you to press harder to make the brush continue to work. Wheel brushes without nuts can be flipped in the opposite direction, and now you have sharp wire tips to continue with your job. By flipping these brushes, you continue to let the wire tips do the work, and at the same time, you are extending the life of the brush. We also have a line of nutted brushes that allow for flipping to take advantage of this self-sharpening. Please reference the Dually on our website, or you can find them on page 63 of our full line catalog. Next slide, please. So just some innovation for power brushes. End brushes, standard end brushes, when used outside of a recess, will flare 2 to 3 times faster than their flare 2 to 3 times larger than their diameter. This flare causes long wire breakage when the brush is used in a corner or on angles. End brushes are intended for use in recesses or inside diameters. Always remember to insert the brush into the recess before turning the brush on. Do your cleaning job, stop the tool, and let the brush come to a complete stop before removing the brush. If you turn on the brush before inserting it into the recess, the brush may not fit into the recess or ID. Our patent control flared end brush is trimmed to remove the outside wires to reduce the flaring of this brush. This brush can be used in cleaning angles, fillet welds to eliminate long wire breakage associated with standard wire end brushes for this application. These brushes are available in 1/2, 3/4, and 1-inch diameters with steel and stainless steel wire. Next slide, please. Circular flare end brushes are versatile and available down to 6 thousandths wire, which provides aluminum fabricators with an option to replace non-woven and quadruple zero steel wool in some cleanup and surface prep applications. Our really fine stainless wire option lets you replace your elbow grease with the speed and efficiency of a power tool without fear of damage to the part. Circular flare end brushes are available in 1-inch to 4-inch diameters and both carbon and stainless steel in a variety of wire gauges to suit your application. Knotted wire bevel brushes are a hybrid between a cup and a wheel. These brushes put the wire tips at just the right angle for cleaning angle and fillet welds. These brushes come in 4-inch and 4.5-inch diameters with steel or stainless steel wire. That's all I have. I want to thank everyone for their time today, and I'll turn it back over to Nate.